morning friends, my name is Rituraj and today we are going to continue lecture number 4 of the chapter DC circuits, that is superposition theorem. So just like all lectures, I will first write down theory and then we will solve an example on superposition theorem. Okay, so now I am writing the theory, you all note it down simultaneously. Okay, so first point, this theorem is applicable for linear and bilateral networks. Second point, if there are number of sources acting simultaneously in any bilateral or linearly bilateral networks then each source acts independently. So note these 2 points. I will also write third point before rubbing. Please note third point. Okay, moving on for the third point. I will write it. The theorem can be stated as in a linear network containing more than one sources the resultant current in any branch is the algebraic sum that would be produced by each source acting alone. All other sources acting alone. All other sources of EMF being replaced by their internal resistances. Okay, so please note this point. Now we will move on towards example. Okay, now moving on towards our first question. I will write it. I will draw the diagram. This is a voltage source which is in series with a resistance. Now there is again one more voltage source in this circuit. This is 6 volts, 12 ohm, 8 ohm, 10 ohm, 15 ohm, 5 ohm and 4 volts. So as we have discussed in superposition theorem that we can calculate current through 5 ohm resistance. Our question is current through 5 ohm resistance is how much? Okay, so this is our branch through which we need to calculate the current. So we need to calculate this question, all this question with a superposition theorem. So as we had discussed, we need to short all the sources, all the EMF sources, and keep only one in a circuit and check the current flowing through this branch, and then we will get some cases depending on number of sources, and then with the algebraic sum of all the results we will get our resultant current. Okay, so this is our question diagram. Now I will rub it to draw our case 1 diagram. Our case 1 will be shorting this 4 volt voltage source and converting and keeping only 6 volt voltage source. Okay. Okay, as we can see here, there was a 4 volt voltage source but I replaced it with its internal resistance. So now for this diagram, let us calculate equivalent resistance of the circuit. So 5 ohm is in parallel with 15 ohm. This entire thing is in series with 10 ohm, which is this entire thing is in parallel with 8 ohm, and again this entire thing is in series with 12 ohm. Okay, so let's solve this. 5 into 15 upon 5 plus 15 plus 10. This entire thing is in parallel with 8 and whole thing is in series with 12. Okay, so solving it, I will just write direct final answer because the calculation will take time. Okay, so on calculation I got my final result at 17.05 ohm. Okay, so now our question is to find out current through 5 ohm resistance. So let us consider current flowing through main branch. This is our main branch, is I. So by Ohm's law we can write I is equal to V upon R equivalent, which is 6 upon 17.05, which turns out to be, I will calculate, 0.35 ampere flowing upwards. So this I will also flow here, and this will get split into this and this branch. So I can calculate it with our current division rule. So I through 10 ohm will be equal to, what will be my that current? Capital I into 8 whole thing divided by into 8 whole thing divided by 8 plus 12, which turns out to be, I will just calculate it, into 8 divided by 20, turns out to be 0.14 ampere. Okay, so I through 10 ohm is this. Now let's calculate I through 5 ohm, which will be equal to 0.14 into 15 divided by 15 plus 5, which turns out to be 0.10, flowing in what will be the direction. This will be direction for 5 ohm. Okay, so you can note this. This is from our case 1. We will just note it as our case 1 resistance. Okay, I will write it here. I dash of 5 ohm is 0.10, flowing in this direction. Okay, so now let's move towards our case 2. I will rub all this and draw the case 2 diagram. Okay, so while solving there was a slight mistake. I just wrote there I through 10 ohm will be equal to I into 8 divided by 8 plus 10, which turns out to be 0.35 into 8 divided by 18. Answer turns out to be 0.15. I just wrote here 0.10 or something else. Now, well, please move back the video. Okay, I will just make a change in this diagram also, so you will understand. Okay, so this was our diagram in case 1, and we had to calculate here I through 5 ohm. I through 5 ohm is I through 10 ohm into 15 divided by 20. So its answer turns out to be 0.1125 going in this direction. Okay. Please note this down. There was a slight correction in the video. I will rub this. Okay, so now moving on for our case 2, that is we are having only 4 volts voltage source. Okay, so calculating for this, we need to calculate current through 5 ohm, which will be I, because this is our main branch. So calculating equivalent resistance, it will be 12, which is parallel with 8. This entire thing is in series with 10, which is parallel with 15, and okay, I will just write it neatly, which is in parallel with 15, and this entire thing is again in series with 5. Okay, so I will calculate it, which will be 12 into 8 divided by 20. 20 how? 12 plus 8 is 20, plus 10, which is parallel with 15, and this entire thing is in series with 5. I will just write direct answer. Okay, where is my calci? 12 into 8 divided by 20 plus 50 plus 10. Answer, what is my answer? 14.8. So this answer turns out to be 14.8. So answer into 15 divided by 14.5 plus 15. Now this answer plus 5 turns out to be 12.5 on approximation is 12.5 ohm. This is my R equivalent. Now by Ohm's law, we can directly say I, which is equal to I through 5 ohm, will be equal to V upon R. So it will be equal to 4 upon 12.5, which turns out to be 4 divided by 12.5. 0.32 flowing in this direction. The current is flowing in this direction. So this is our I through 5 ohm case 2. Okay. Now let's apply the superposition theorem. I will rub this first. So by superposition theorem, I through 5 ohm will be equal to algebraic sum of I through 5 ohm in case 1 plus algebraic sum of 5 ohm in case 2. So as we can see, the directions are opposite, so eventually they will get a subtract, and the final direction will be of that whose magnitude will be high. So this magnitude is quite high, So we will take this as our final direction. Now I will just perform the subtraction, and my answer turns out to be 0.2075 flowing in this direction. Unit is ampere. So this is our final answer. Please note it. Okay, so now please note it. I will give you a homework question and we will end our lecture. Okay, so I am writing your homework question. Okay, it is like this. Okay, so this is my diagram. This is 15 ohm. This is 4 ampere. This is my 10 ohm, 1 ohm. There is one more resistance here also, which is of 5 ohm, and this is 2 volt voltage supply. Okay, so it's my kind request that don't use source transformation in superposition method, as it will deviate you from your answer. My question is to find current through 10 ohm is how much, and its answer is 0.4343 acting downwards. Okay, so thank you for watching this video. Like, share and subscribe this new amazing channel. Thank you.